Okay, this is kind of a quick production for Carrie Cassidy. Kind of an overview of Giza and what I know. And okay, right off the bat, this is where Giza is. There used to be a lake, Lake Morris. It was the size of Lake Erie, and according to Herodotus, it was actually hand dug. Whether that's true or not, I don't know. But it used to have a lake. Put a channel across here. They dug that. Put a dam across the Nile, and there are miles and miles and miles of tunnels everywhere throughout the whole area. Okay. This is from the Oriental Institute of Chicago. It's one of their images. This Great Pyramid's there, and as you can see, it has the causeway down to the Nile, and of course the middle and the smaller, the Red Pyramid. And then the Nile was along here. This is where the Sphinx is here. Right here is the Sphinx Temple. The Nile was up to the base of this, and then down across here. It was much lower, but okay. Topographical. So it shows Great Pyramid here, and it shows Causeway. This is where the Nile used to be. You can see this is the old. Right there is where the Sphinx Temple is. This is actually from Oriental Institute, and around all the pyramids was a retaining wall that is completely accepted. That's standard knowledge and is not arguable. This is Colonel Howard Weiss's drawing. He did it was very extensive in the late 1800s, or early 1800s. But there was a well shaft that they dug out. It was called the Charm, but it was a well shaft that was in front of the Great Pyramid. It's no longer in existence, as are many things, many features of the Great Pyramid. But they dug it down to 47 feet. And this is, okay, now this is a wire diagram, Oriental Institute, and so you can see the retaining wall, and then this is the part that I've done. It's just the lower portion, which is the subchamber, descending passage. But you can also see that here's the causeway going down to the Nile, so it shows the relative elevation of the Nile, which is down here, with the subterranean chamber, which is 100 feet below bedrock. The original theory for some sort of water pump would have been for a lock system, and this is, I believe it's from Greg Martin, did this this picture, which showed Kunkel's vision, who came up with the idea of a water pump for elevating blocks, as you can see here, just by using some water locks, you know, little doors and water coming down, and a couple guys drag it up and open the little doors. Very, very incredibly simple and incredibly quick. Great idea. Just old map diagram. For me, the most interesting thing was the water tables. Shows relative water table of the Mediterranean, water table of the plateau, and the subterranean chamber in relevance. Okay, now this is a satellite image from the Russian satellite, and high res, and it's at a slight angle. And so what I have done is I wanted to determine where various things were with exactness. I actually took Great Pyramid here, and I took the four corners, the exact four corners, and was able to then triangulate here, which shows midpoint, and I did from where the tapers are on each side, and crossed it there, so double tapered, and that is the midpoint at base level. And I did the peak, midpoint at the peak, and that's approximately 500 feet, so I subdivided the z-axis here to 5 parts, so that's approximately 100 feet, and then I dropped on the z-axis straight down 100 feet to the subchamber, and that gave, and then I did the offset, gave the exact point of the pit of the subchambers at 100 feet below the ground. So that's exactly where the pit is. And what I did that for was that I had determined right here, which is the Sphinx Temple. The Egyptian Water Department had drilled right there and drilled down 30 feet looking for the water table and determined the water table, and they hit rose quartz granite at that point, which means, since it's not indigenous of the area, that means something's there, and that would have been the relative elevation and possible location for the exit tunnel. Now, all the indigenous teachings say that all the pyramids have tunnels that went down to the Sphinx area. So this is the Sphinx area. So I determined the final location, the destination of where the tunnel would have come out. Happens to be a later building here was offset by 45, just interesting. But what we found is that it is exactly, absolutely exactly 45-degree offset. And that is completely relevant to the pit shaft. That is absolutely relevant, and I'll show that a little bit later. And then another interesting thing was the dead end shaft, which is kind of the little purple dotted line. If you extend it out, that's 100 feet below the surface, there is a multi-room, at least three level chamber in here. It's called the water shaft, or Tomb of Osiris, or whatever latest name they use. And that's the exact point of the entrance. If you go down 100 feet, and it took 4 years of pumping to pump the water out, there's a tunnel that goes in this direction. And that's the exact location, same elevation as the dead end shaft, and that strongly suggests that there's a major complex of tunnels under there. There's other evidence, but that is, concrete. Okay, that's a really crappy drawing, but it shows that water shaft. It shows multiple rooms, another shaft down, multiple rooms, and then drops down to a water area with some columns, etc. Okay, this is a very nice drawing which shows, this is the room I did. It's a dead end shaft. It goes like 47 or 57 feet to a dead end, and then you can see the pit here, and you can even see that they extrapolated an extra depth. So it looks like the basic subchamber, and then so that's the descending passage. Interesting couple items. This says inset stones, and it's pointing towards this here, and those are granite inlays. And there's actually some insets and a round hole here. And then right here you see what's called Petrie's granite block, which is interesting. Stuff you just don't see. Interesting. And then this was another one of the drawings, and at the bottom of the drawing it says right in here, just shows the subchamber side and the top, to the best of their abilities at the time, because it wasn't fully excavated. It says right here, Paring's excavation 36 feet deep. So it was actually dug deeper, and now it has been filled in. And this is just a close-up, so you can actually see that is exactly what that says from 1929. History is erased constantly there. This just shows subchambers down here. It shows that the King's Chamber is directly above it. Okay, a couple pictures of subchamber. This one here. Okay, it's 57 by 27 feet. So this here is about 6 feet, and it's about 7 feet up to here. And there's some fins here and here, and some unusual fins here, and then a little channel here. And this is where the pit is, down in here. And now they put rails so they don't fall in. And then this kind of shows a side profile of the fins here. It just kind of shows the face and some fins. This is actually Robert Schock standing. This is one of the fins, and he's standing about the plateau area. He's about, I think he's like 6'4", and this is ceiling. So from the plateau, upper plateau, up to the ceiling is quite large. Interesting black residue that is not smoke. Very old, and it's not the color of limestone. It's just above people's hands, and they've been pressure washed hitting the rim. And this was Edward Kunkel's original drawing, and he had thought that this was some sort of whirlpool chamber, and he said wasn't sure what was over here in the fin area. He couldn't figure it out, and he had believed that it made a whirlpool and then it reversed and sent water back up. It didn't work. Anyways, interesting point right here. This says northwest corner of the rock-cut subterranean chamber in the Great Pyramid of Giza, showing a small recess in the west wall. It's the farthest west of the thing. Also, Stanley looking over the thin ridge of rock which bounds the south side of the narrow stall-like cutting in the north corner of the chamber. It's a very significant little spot because it actually extends up, it goes in. It's the only spot. And on my model, this is model, I added that, and that is actually the absolute best place to remove air. It's at the back, up. Okay, this is showing basically what I think would be and remove the air, and just a small, like, some simple valve that just allowed whatever gas that accumulated in the room to go up to the Queen's chamber. Okay, now this is the actual complete components of the working model. You have retaining wall, water from the Lake Morris gravity feed, from the tunnel, and just drops down, goes into the subchamber here. Dead end shaft over here. Well, if you have a check valve and the check valve is closed, it is a dead end. Okay, just extend down the shaft, and notice that little corner and that's how they would have made it. And so that's to the waste valve, to the Nile River. Waste valve is extremely simple. Anybody could have made one. It's very, very simple. Actually, let's see here. So that's all that's required for the pump to run. You don't actually even need this air removal line. So what I actually did, I made for the model, this is equivalent of this shaft with the angle. You notice it's just the way they would have made it. It's just vertical, horizontal, so just a real normal union. It is significant, though. It will be significant. Okay. Now, if you look at the model, this is looking into the room. The water shoots straight across the room and strikes the far wall, and water is deflected. It goes perpendicular, and so that shows how it hits, actually goes to the output, it's shot towards it, plus it's also deflected. This is kind of showing that eastern wall. It shows how it goes across, and this is the dead end shaft. It shows basically how it's deflected. There's flow that curls on that wall. There's some that's deflected in the various directions. Some that swings around and drops straight down. And they actually incorporated the roof of the subchamber as a third dimension of the fluid model. So they were thinking 3 dimensions, not just a little toilet whirlpool. It's a 3-dimensional vortex chamber. Creates beautiful vortex. So looking at the face of the fins, this is the simplest diagram possible. It doesn't show most of it, but it shows like part of the flow goes across the face. Step, they have water that comes down through this channel, and that redirects the flow in this direction. They have some here. It comes down from this wall and curls, and then that redirects the flow across the room. They've got a mid-level flow that drops down here. They've got a flow that comes here, and it actually circles the plateau in this direction, and then it goes back, the back of the fins, they have some that comes between this fin and this fin. Two different velocities. This is faster, it's a little bit slower. So actually ink, this is how I determined it. This ink from the entrance room goes across. It actually shows it going down on the floor at this level here, dropping into the pit, and then going across here, hitting the step face, and then right there getting redirected by this channel. So it explains the channel. It redirects fluid flow. This is overhead. This is a fluid jet going in. You can actually see where it's lighter in this area because there's not ink there. And I have a jet here, ink jet here, 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 here. You can actually see that's how it was determined exactly where these go. You have a lower level, it comes across here, hits the face, then curls over here. You have a mid flow, you have an upper flow that uses the ceiling. This uses the ceiling, goes across the room. This uses the ceiling and drops down to the pit. And this goes to the ceiling and circles and actually presses down, lowers the overall level of the jet. True genius. There's ink that shows absolutely there's that channel, it's redirected. That's the sole purpose of that. Every part of this has a function. There's ink coming down the channel, and it shows it redirecting. As you see some here that ink's coming out here and it's coming across. So you have it going in different directions. You have it coming down this way and across. You have it down. Everything is directed. Here, this is that step. You see right here, there's ink here and there's ink here. You see how it curls around. And I actually did one inkjet here, and at this point it goes up, but actually the ink, if you put it here, it goes down. And then here you can see it goes across the ceiling and drops down, curls, and you have the two channels. This has it's coming down this way, starts curling, and this is a little bit faster, higher velocity. This is lower velocity, and it also comes down, curls, and creates a curling vortex for the roll layer that shoots out this direction. This is the basic, I think 1800s basic hydraulic ram pump design. This was a cannonball chunk of pipe. Velocity increases enough, it slams shut here, creates pressure spike. They got a little check valve here. High pressure comes in here, and air to cushion it and stabilize things and keep it from blowing up, and just start pump cycle over. That's basically what this is, but you don't need this valve and you don't need an air chamber. So the world's simplest pump, you can remove two parts. Not too bad. This is basically how the waste valve works. This would be the horizontal valve at Giza, and just sort of explaining that fluid's coming down and it starts moving this rectangular block in the shaft, and comes over, moves, slams shut. At that point it creates compression wave, high pressure spike. It's a shock wave, literally shock wave, and that sends a shock wave, high pressure shock wave, up the pipe at the speed of sound of water, and also creates a low, extremely low pressure rarefaction wave which follows it. It's exact opposite. So that low pressure sucks the valve back open immediately, because it's super low pressure. You have super low pressure, a higher pressure here, it opens out, and these send up the pipe. Here's a couple pictures you won't see. Other items that you never see about Giza. This here is a steel door. This is on the east side of the Great Pyramid. The steel door, tunnel that goes under the Great Pyramid. These are shafts that go down next to the Great Pyramid, east side. And these were some sort of water shafts here. And that's just showing the shafts, and then a bunch of garbage in them. You won't see these. You won't see most stuff. If it's important and it doesn't fit, if it doesn't fit, they don't include it. And this is a really old. I gave this to Chris Dunn. I wanted him to look for erosion. So this is like 2000, back in 2000, 10 years old. But I was trying to explain to him how the velocity, the weight, the fluid coming through here actually created a rotational momentum. It created inertia at this level. So you've got rotation, and it's trying to force it out. So even if you stop the impulse, you still have it shooting across the rim just from the momentum, which encourages the whole pump system. That's just a picture that shows overwhelming number of fluid flows. Very specific. It's absolutely overwhelming. And that is it. Okay, this is my very quick guerrilla video for Carrie, just showing. This is the subchamber model, so it's 48 to 1, or 1 to 48, so it's 1/4 inch to the foot. Now this was the shaft I showed earlier. Now the pin shaft in the room is offset by 45 degrees. Now the line down to the Sphinx area, from the Sphinx temple, this is the shaft. And if you take the room and drop it down, that is exactly 45 degrees. And that is the precise reason why they offset that particular shaft at 45 degrees. Nobody has any clue. That's a specific reason. It's for the shaft at the bottom. It's for the angled connection. Now also, why nobody has a reason why this shaft is offset from the eastern wall. Now this is the entrance. It's 3 foot by 3 foot, and if you have, let's see here, if you have water shooting in across, the water misses the shaft, which has a downward velocity, and it comes across here. That's the dead end shaft, and that's the output. What you see is it directly strikes the dead end shaft, and so that's where the output is. That's the high velocity. It's a continuous flow straight out, plus you've got the rotation, so the rotation encourages it. And on this model, there's